Imagine, for a moment, that you are standing on a beach at night. The sand is cold beneath your feet. The waves are whispering something ancient, something you can almost understand but never quite catch. And above you stretches a sky so impossibly vast that it makes your chest ache just to look at it. 200 billion stars in our galaxy alone, 2 trillion galaxies in the observable universe. Numbers so enormous that your brain refuses to truly hold them. It just files them away as a lot. And somewhere, in all of that staggering immensity, you find yourself asking the same question that humans have whispered for thousands of years, around campfires and through telescopes, in laboratories and in dreams. Are we alone? But tonight, I want to ask you a different question. A stranger question. A question that the great physicist Richard Feynman might have asked, with that mischievous grin of his, leaning forward in his chair. Not, are they out there? But, if they are out there, why haven't they come? And I'm going to tell you something that might disturb you. Something that, once you understand it, you won't be able to unsee. Because the answer isn't what science fiction has been selling you. The answer isn't romantic. It isn't hopeful in the way you want it to be. The answer is something much, much stranger. Stay with me. Asterisk. The setup Eintroducing Feynman asterisk. Richard Feynman was a peculiar kind of genius. He won the Nobel Prize in Physics in 1965. He helped build the atomic bomb at Los Alamos. He cracked safes for fun. He played the bongos. He once said that if you think you understand quantum mechanics, you don't understand quantum mechanics. But the thing that made Feynman special wasn't just his intelligence, it was his honesty. His almost childlike refusal to pretend he knew something when he didn't. He had this way of stripping problems down to their bare bones, of asking the dumb questions that everyone else was too embarrassed to ask. And one of the questions he wrestled with, quietly, throughout his life, was this question of the cosmos, of whether anyone else was out there, of whether the universe was teeming with minds, or whether we were a single, flickering candle in an endless dark room. Feynman never claimed to have the answer, but he had a way of thinking about it. A way that, I believe, brings us closer to the truth than all the Hollywood spaceships and government UFO hearings combined. And that way begins with a simple, uncomfortable admission. The universe is not built for visitors. The first wall, distance. Let me try to make this real for you, because numbers on their own are dead things. They mean nothing until you can feel them. Our nearest star, not counting our own sun, is called Proxima Centauri. It is 4.2 light-years away. Light-years. That word sounds poetic, doesn't it? Almost gentle. But let me translate it. Light is the fastest thing in the universe. Nothing we know of can travel faster. Light travels at 186,000 miles per second. In 1 second, a beam of light could circle the Earth 7.5 times. That's how fast we're talking. And yet, even at that godlike speed, it takes light 4 years and 3 months to reach Proxima Centauri. Now, our fastest spacecraft, the Parker Solar Probe, travels at about 430,000 miles per hour. Sounds fast, right? At that speed, it would take us, roughly, 6,600 years to reach Proxima Centauri. 6,600 years. The pyramids of Egypt are about 4,500 years old. So if the ancient Egyptians had launched a Parker Solar Probe with our fastest current technology, it would still be roughly 2,000 years away from arriving, and that's just the nearest star. A star which, by the way, doesn't even have a confirmed habitable planet around it. The galaxy itself, the Milky Way, is 100,000 light-years across. If you wanted to cross it at the speed of light, the journey would consume civilizations. Empires would rise and crumble before you reached the other side. Feynman understood this. He understood it not as an abstraction, but as a physical truth. The universe doesn't have walls, but it has something far worse. It has distance. And distance, in cosmic terms, is a wall made of time itself. So already, before we've even started, we have a problem. Even if aliens exist, even if they're out there right now looking up at their own night sky, asking the same questions we're asking, the sheer geography of the cosmos may make a meeting impossible, but that's only the first wall. And honestly, It's the easiest one to overcome. Asterisk, the scientific wall time. Here's where it gets stranger. Most people, when they think about aliens, imagine them existing now, right now, as you watch this. Somewhere out there, a being is sipping its equivalent of coffee, looking out a window, wondering about us. But the universe doesn't work that way. The universe is roughly 13.8 billion years old. Modern humans, Homo sapiens, have existed for about 300,000 years. Civilization, as we'd recognize it, is maybe 10,000 years old. Radio technology, the kind of thing we'd use to detect or contact other civilizations, is about 130 years old. 130 years out of 13.8 billion. If you compress the entire history of the universe into a single year, all of human technological civilization would occupy the last quarter of a second before midnight on December 31st. Now think about what this means. For two civilizations to meet, to actually communicate, to exchange ideas, they have to overlap in time, not just space. They have to both exist, both be technologically capable, and both be close enough that a signal sent from one could reach the other within their lifetimes. The window is impossibly thin. A civilization could have risen on a planet 1,000 light years away. They could have built cities, written poetry, launched ships into their own sky. And then through war, through climate, through asteroid, through their own foolishness, they could have vanished, long before their first radio waves ever reached us. By the time their signal arrives at our telescopes, they might be a 1,000-year-old corpse of a civilization, bones in the dirt, ruins under alien sand, and we'd be listening to a ghost. This is what Feynman understood, perhaps better than most. He had seen, with his own eyes, what civilizations could do to themselves. He had stood in the desert of New Mexico and watched the first atomic bomb light up the sky like a second sun. He knew that intelligence and survival are not the same thing. That cleverness is not wisdom. And he wondered, sometimes, whether every civilization eventually invents the tools of its own destruction, and whether most of them don't make it past that test. The universe might be a graveyard of brilliant species, each one rising, each one calling out, each one falling silent. And the silence we hear when we point our antennas at the sky might not be loneliness. It might be the silence of a war that's already been lost, 1,000 times over. By 1,000 civilizations we'll never meet. Asterisk, the third wall, the Feynman perspective. But here's where Feynman would lean forward. Here's where he'd put down his bongo drums and look at you with those sharp, hungry eyes. Because distance and time are physical walls. They're real, but there's a third wall, and this one is the one most people never think about. The wall of understanding. Feynman had a famous saying. He said, "I think I can safely say that nobody really understands quantum mechanics." He didn't say this to be humble. He said it because it was true. The universe, at its deepest levels, behaves in ways that don't match our intuitions. Particles that exist in multiple places at once. Time that bends. Reality that seems to depend on whether someone is looking at it. And Feynman recognized something profound. The human mind evolved on the African savanna. It evolved to find berries, to avoid lions, to track the movements of small animals and read the faces of other humans. It did not evolve to understand the cosmos. The fact that we understand anything about quantum mechanics or relativity is a kind of miracle, a strange overflow of a brain designed for completely different problems. So now consider an alien. This alien evolved on a different planet, different gravity, different chemistry, different sun, maybe different senses entirely. Perhaps it sees in radio waves or feels magnetic fields the way we feel warmth. Its brain, if it has anything we'd call a brain, was shaped by pressures we can't imagine. Why on earth would we expect to understand such a creature, or for it to understand us? We share no language, no reference points, no common ancestor. We don't even share the same kind of time perception. What if the aliens think 1,000 times slower than we do, and an entire human civilization rises and falls in what feels to them like a single conversation? What if they think 1,000 times faster, and to them we appear as motionless as statues, interesting perhaps, but no more capable of conversation than a tree? Feynman, in his lectures, often warned his students about anthropomorphism, the tendency to project human qualities onto things that aren't human. We do this with our pets, we do it with our cars, and we certainly do it with aliens. Look at every alien in every science fiction movie. They have 2 arms, 2 legs, a face. They speak, even if their language is different. They want things, power, conquest, peace, escape. They have motives we can recognize. But why would they? A real alien might be so foreign that we wouldn't even recognize it as alive. It might be a vast cloud of plasma drifting through a nebula. It might be a colony organism the size of a continent. It might be something so strange that our brains literally cannot perceive it as a single thing, the way an ant cannot perceive a human as a coherent being, only as a series of impossibly large columns moving through its world. And even if we did meet such a creature, what would we say? What could we possibly have in common? This is the 3rd wall, and it's the tallest of them all. Ask, the turn, the Dak Forest and the economics of Kant. Ask. Now, let me ask you something, and I want you to actually think about this, not just nod along. If you were an advanced civilization, a civilization that had survived its own atomic age, that had crossed the gulfs of space, that had achieved technologies we can't even dream of, why would you visit us? Think about it. Really think. We have nothing they need. Water? It's in every comet. Metals? They're in every asteroid. Energy? A single star produces more energy in 1 second than humanity has used in its entire existence. We are not a resource worth crossing the cosmos for. Knowledge, then? Are we so fascinating? Maybe, but consider, an advanced civilization could probably observe us from light years away. They could read our radio broadcasts, watch our electromagnetic spectrum bloom and shift. They wouldn't need to land on the White House lawn. They could learn everything they wanted to know about us without ever revealing themselves. And here's the colder thought, the one that Feynman, with his deep honesty, might have nodded at quietly. What if the smart thing to do, when you're an advanced civilization, is to stay quiet? There's a theory called the dark forest hypothesis. It comes from the Chinese science fiction author Wu Xixin, but it has roots in serious thinking. The idea is this. The universe is like a dark forest at night. Every civilization is a hunter, moving carefully through the trees. You can't see the other hunters. You can't know their intentions. And the laws of survival are simple. If you make a sound, you risk being heard. And if you're heard by someone more dangerous than you, you die. So the rational thing, the only rational thing, is to stay silent, to listen, but never to speak, to watch, but never to wave. If this is true, then the universe could be full of civilizations, teeming with them, and every single one of them is hiding, crouched in the dark, holding its breath, listening for the footsteps of something worse. And here we are, tiny, naive, blue planet Earth, broadcasting our television signals into space, sending out probes with maps to our home, singing into the dark forest at the top of our lungs. Feynman might not have phrased it this way, but he understood deeply that the universe is not a friendly place by default. It is not designed for us. It does not love us. It simply is. And our survival on this little rock is far more precarious, far more accidental than we like to admit. Asterisk, the Pew Revelation. Asterisk, the Pew Revelation. But I promised you something stranger, and we haven't gotten there yet, because everything I've told you so far, the distance, the time, the strangeness of alien minds, the dark forest, all of that is, in a sense, the easy answer. Those are problems of physics and strategy. The deeper question, the question Feynman might have whispered to himself late at night, is this: what if we're not even looking for the right thing? Let me explain. When we search for aliens, we look for things that resemble us. We look for radio signals because we use radio. We look for planets in the habitable zone, meaning habitable for us. We look for water because we need water. We look for carbon-based life because we are carbon-based life because we are carbon-based. But this is like a fish, trying to find other intelligent beings by searching the ocean for things that breathe water. The fish would look at a bird flying overhead and see nothing, just empty sky. It would look at a human standing on the shore and see only a strange, dry, motionless thing. The fish would conclude that the ocean is the only place where life can exist, because the fish cannot imagine an existence that is not its own. We are the fish. The universe could be teeming with intelligence right now, intelligence that doesn't use radio, doesn't live on planets, doesn't experience time the way we do. There could be minds embedded in the structures of stars themselves. There could be civilizations that exist in the gaps between galaxies, communicating through gravitational waves we don't yet know how to read. There could be beings so vast and so slow that they think one thought every million years, and to them, our entire civilization is an electrical flicker, gone before they finish blinking. Feynman, more than almost anyone, understood that what we know is a tiny island in an ocean of what we don't know. He used to say that the most exciting words in science aren't eureka, they're that's strange. Because that's strange means there's something new, something the old framework doesn't account for, and the universe is full of that's strange, dark matter, which we can't see but which holds galaxies together. Dark energy, which is pushing the universe apart faster and faster. Quantum entanglement, where particles seem to communicate instantly across any distance. We don't understand these things. We've named them, but naming is not understanding. What if intelligence, the kind we'd call alien, is hiding in one of these mysteries we haven't cracked yet? What if it's been right in front of us all along, and we just haven't developed the eyes to see it? What if the aliens have already visited, not in flying saucers, not in the way the movies show, but in ways so subtle, so woven into the fabric of reality, that we mistook them for physics? I'm not saying this is true. I'm saying, and Feynman would say, that we don't know. And the moment we think we know, the moment we get certain, is the moment we stop being scientists and start being priests of our own ignorance. Asterisk. The QA truth. So here we are, standing on the beach again. The waves still whispering, the stars still burning, and I want to leave you with the thought that I think Feynman would have wanted you to leave with. Not despair, not fear, something gentler than that, something stranger. The aliens may never visit us, not because they don't exist, not because they don't care, but because the universe is built in such a way that meeting may simply be the rarest event of all. The distances are too vast. The times don't overlap. The minds don't translate. The risks of speaking are too great. And the very nature of intelligence may be so much wider than we imagine that we're searching for our reflection in a sea full of creatures we'd never recognize. And yet, here we are, on this single fragile planet, with our brains evolved for berries and lions, somehow capable of asking questions about quantum mechanics and the age of the cosmos. We are, ourselves, a kind of miracle, a kind of impossibility. Feynman once said something I'll never forget. He said, "I, a universe of atoms, an atom in the universe." Think about that. You are made of atoms forged in the hearts of dying stars. The iron in your blood was cooked in a supernova. The carbon in your DNA is older than the sun. You are, quite literally, the universe trying to understand itself. The cosmos, after 13.8 billion years of darkness and motion, has finally produced something that can look back at it and ask, why? Maybe that's the answer to the great question. Maybe we are the aliens. Maybe every conscious being on every world is the universe waking up in a different place, alone, but never truly alone, connected by the same atoms, the same physics, the same desperate, beautiful curiosity. The aliens may never visit us, but in a deeper sense, they already have. They are already here, looking out through your eyes, wondering, just like you, in this exact moment, are we alone? So tonight, before you sleep, step outside. Look up. Don't try to find the aliens. Don't search for ships or signals or signs. Just look. And ask yourself this. If the universe is so vast that no one will ever cross it, why did it bother to make a creature capable of imagining the crossing? There's a reason. There has to be. We just haven't figured it out yet. But that's the thing about the universe, isn't it? It always saves the strangest answers for last. Stay curious, stay humble, and come back soon, because there are still questions out there in the dark forest waiting for someone brave enough to ask them. Until next time.